Welcome to the 9th lecture in the course, just a moment, 9th lecture in the course Computer Numerical Control of Machine Tools and Processes. We will be talking about programming practice in this particular lecture. What is programming practice? Whenever we are giving instructions to the machine to carry out a definite number of machining operations, then there is a specific way in which we can give this instruction, and this is generally called computer numerical CNC programming. Okay. It is going to be a sequence, that is when a computer program on being executed successfully guides the machine tool through the sequence of motions and actions necessary for machining a part, or simulates such motions and actions on a graphic user interface. It is an example of computer numerical control programming, or simply CNC programming. Okay. So, let us have a quick look how CNC programming is carried out. First of all, the basic simple way of communicating to the machine control unit about the motions and operations to take place, it is the G and M code programming. Some basic codes are written down, and the G and M code programming language is simply to get the motions that are to be executed and also the auxiliary operations. That means the non-cutting but essential operations. For example, say coolant on, coolant off, then tool change, then declaration of tool length and diameter measurements, etc., etc. So, if the codes are preceded by the letter G, they are called G codes or preparatory functions, and they are generally connected with motion. And if the codes are preceded by M, they are called miscellaneous functions, and they are generally concerned with the non-cutting auxiliary operations. Now, there might be other codes as well. There might be 3-letter codes, there might be parametric functions, etc. In addition to G and M codes. They basically help us to carry out the operations in a better fashion. So, G codes will be preparing the machine controls for the type of motion, and M codes for non-cutting operations in general. So, M codes are sometimes also referred to as managerial or auxiliary commands. Let us look at the type of programmed motions that we are going to get from a general purpose continuous control machine. Continuous control machines can carry out all point-to-point operations, but point-to-point operation machines cannot carry out certain motions which are possible in case of continuous control. So, there are 4 basic types of motion for continuous control CNC machines. First of all comes the rapid traverse motion. This motion is generally used to take the tool or the cutter to the point at which it is supposed to carry out the cutting action. Second, the linear motion. So, rapid traverse, as the name implies, rapid traverse motion generally takes place at the highest possible speed available for that particular axis, unless there are other factors to modify that. The linear motion, linear motion is also possible at controlled feed rate. What does it mean? It simply means that you can move from one point to another along a straight line at a controlled velocity. Control means predetermined. You can assign a particular velocity for that particular movement, and that is generally referred to as feed velocity. The other 2 types of motion, they are the circular clockwise motion at controlled feed rate. So, as the statement implies, the motion is going to be in a clockwise direction, naturally in a circular manner, and the feed rate will also be controlled along this path. And in the same manner, you can also have counterclockwise motion, circular manner at controlled feed rate. These are the 4 basic motions which will always be available. Apart from these, if some machine has some other specialized motion available, that is a specific case. So, let us have a look how they are depicted actually. So, G00 is rapid traverse and its format will be G00 followed by, the syntax reads this way, G00 code followed by the target point coordinates. The target point coordinates in this case, they are x 200, y 300 and z 400. Unless otherwise stated, we will understand, we will take it this way, that this refers to the coordinates of a particular point on the machine coordinate system. By machine coordinate system, say in case of a milling machine, we will understand it is a coordinate system fixed on the table, as if by paper and glue you have stuck a coordinate system, a graph paper on the machine table, and when the machine table moves, it means that other items are moving relatively in opposite directions in the coordinate system of the table. So, it is going to a particular point whose coordinates are given here as 200, 300, 400. G01 in a similar manner, it refers to linear motion as we have discussed at controlled feed rate, and its syntax is G01 followed by target point coordinates, and since it is taking place at a definite rate, the rate is mentioned as F200, which reads unless otherwise defined 200 millimeters per minute. We will understand this way in our discussion. It reads 200 millimeters per minute feed rate. G02 circular clockwise motion can have different ways of expressing the data, and there are I have given 2 such ways. There are other ways also. For example, we might write G02 followed by target point coordinates x 250, y 350 and z is not mentioned here, because generally these circular motions will be associated with a particular plane of action, and in this case it is xy plane. The radius along which this rotation is supposed to take place, it is 150 millimeters, and the feed is supposed to be 200 millimeters per minute. Shall we have a quick look in a piece of paper how this will be coming out? Let us see. This one is the first point, say the initial point, and this is the final point. So, this point must be equal to 250, 350. You might ask, what about this point? I do not know its coordinates. Well, this is the last point at which it was residing when this command is executed. Let us say this point is the previous G01 coordinates 220, just for the sake of having a definite concrete values, 320, that is fine. So, after that what is stated? It is stated R150 and G02, we have to move clockwise manner. You might say, why not this one? Well, this will be accepted if this radius is R150. My drawing is not very good. Please be please understand that this is supposed to be part of a circle with radius 150, and the motion of the tool will start from here and it will end up here. Is there any other path which will be satisfying all these conditions? That is, this is the start, this is the end, this is essentially clockwise, and this is R150. Yes, there is a possibility that it might start this way, out of our space of consideration and end up coming here and end up here, where this radius is also 150. What about that? So, if there are 2 possible solutions to the motion that has been asked for, then what path is the tool going to take up? The answer to this is that unless otherwise stated, it is always going to take the minor arc. If you specifically want this particular path, the longer path, the major arc to be executed, then something else has to be stated. What is that? In general, in machines, if we come back to the this one again, in general some machines permit that you can just add a minus sign in front of this numerical value just after radius. That means, if you write r minus 150, in some machines they will permit the cutting of the major arc. Otherwise, if you do not state anything, the default case, that means the thing that is going to happen if nothing else is stated, that is going to be the minor arc, the smaller arc. Okay. Now, coming back to this one, to other formats which are allowed. This one says G02 x y of the target point followed by center coordinates 270 and center coordinate x 270, center coordinates y 370 and feed. So, this means that ambiguity which was existing in the previous format, that is done away with by actually choosing the center coordinates. But here you have to be very careful that you have to give the correct center coordinates. If you give some incorrect center coordinate, it will give you an error message and the program will not be executed. There are other ways also of giving command for circular interpolation where I and j are made use of, but we will not be discussing it at this moment. When we are discussing interpolators, we can take up that particular definition. Coming to circular counterclockwise motion, the only difference here is the G03 term instead of G02 term. All other things I am sure you can understand by applying some common sense. This is an actual example. If we see it visually, G90 means these are the different lines of the CNC program. Each line may correspond to a declaration about some data, or it might be corresponding to an actual movement. The first line corresponds to a movement. G90 means absolute system. That means, we are referring to the points by their absolute coordinate values. So, there is a point which is being referred to as 20, 30 and it is this point. So, we are saying that go fast to this point G 20, 30. So, wherever the tool might be residing, from there it moves fast and reaches this particular location at highest possible speed. After that, nothing else is mentioned, so that it means that G00 is still active. So, it is still going to move fast, and where is it going to move? To y50. What about x? It does not change, and therefore, it is not mentioned, and therefore, it simply moves up only in y, so that it attains a position y equal to 50 and stops there. So, the coordinate location of this point will be 20, 50. After this, we have a movement here which involves movement both along x and along y. So, it moves along this path until it reaches the point 100, 100, and the feed value for that motion, since it is G01, this feed value is mentioned. What if you do not mention this feed value in a G01 command? If you have previously executed a G01 or G02 command, or mentioned some feed value in a declaration statement, then it will adopt that value. But if you have not given that, generally machines will stop giving an error symbol, that is insufficient data has been declared. So, in order to avoid that, please be careful always to declare a feed value for G01, G02 commands. After this, there is a circular movement, and we write G02 x40, and y is not mentioned. So, y remains the same, and R200. So, it moves from simply from this point to that point. We have already discussed this, how this is done, and it reaches this point by circular interpolation. After that, M30 is end of program. Starting declarations. So, when a program is starting, it might be starting with a number of declarations. What sort of declarations are we talking about? It might be stating whether it is adopting the absolute system of reference to coordinate values, or it is referring to incremental values of movements. That means, if it says G91 x30, it simply means that the incremental system is being adopted by G91, and x30 would be referring to a movement which is 30 millimeters along x. It has nothing to do with the absolute coordinate value of the particular position of the tool. It might have a number of options activated previously by, say, the previous command, which are to be cancelled. For example, what are these options? What can be these options? It can be that you are declaring that the tool is of such and such length, workpiece of such and such height, the tool is having this kind of diameter, the tool is supposed to carry out drilling operations unless it is asked to stop that. Okay. The tool might be asked to carry out, say, spot facing operation at different locations. Wherever it goes, it is supposed to spot face. You might have a command for cancelling that. So, all sorts of cancellations and cancellation of options previously opted for, they might be, which might be active still, they might be cancelled in that first line. So, there might be a declaration on the type of coordinate system or offset from such a coordinate system, or you might be having the choice of a particular coordinate system or the rotation of a coordinate system. Things like that might be declared in initial lines, or whether there is a declaration on tool and cutter, which we have already discussed. This is a typical line, starting line of a program. For example, you might be having declaration that G90 absolute system, G40 cancel tool compensation. Okay. Tool compensation means some declaration on the tool length, workpiece height, tool diameter, etc. Sorry, tool diameter. Tool diameter declarations are being cancelled by G40. Then comes what is the importance of tool diameter? Whenever you are cutting along the periphery of a particular part, if you declare the tool diameter, then the way in which it is connected with the part profile, then the machine can do some calculations which otherwise would have had to be done by you. We will, when we discuss programs, we will be definitely discussing this. So, G40 cancellation of tool diameter or tool radius compensation, G49 cancellation of length compensation, G80 cancelling tool cycles which have been previously activated and now need to be cancelled. G53 is a coordinate system option command, that is, you are asking for a definite coordinate system. Okay. That means you might be opting for work coordinate system declaration, you might be opting for some coordinate system which is offset from the machine coordinate system, etc. X0, Y0, Z0 gives us the particular values connected with such a coordinate system which you want to declare. Then you might be having M06, this is an M command which is concerned with tool change. Suppose you want a particular tool to be loaded on the spindle, and that tool has a name 12, that is, tool is designated a number. It might be associated with the very tool itself, or it might be associated with a particular location on the tool storage device, and the tool happens to be residing there. So, the machine is being instructed, go for a change of tool, so that tool number 12 or tool residing in seat number 12 is loaded onto the spindle. This is the command. So, after the execution of this command, you will find that particular identified tool is mounted on the spindle of the machine. next comes, or if it is some other kind of machine like turning center, that will be in the in the location, so that it can start a cut. Maybe a turret is rotated, so that that tool comes into the working position. So, there might be other commands. We will be going through all these commands in more detailed fashion when we take up a particular program. So, there might be various movements, it might have calls to different subroutines. What are subroutines? Subroutines will be a cluster of commands which are given a separate entity like a program, and it might be called called from a particular program in order to be executed, sometimes a number of times. What is its utility? That means it can be called to be executed at any particular location. It is generally location independent. Okay. So, suppose you want a number of operations to be executed at different locations, different number of times. So, you might be asking the subroutine to carry out those operations at those locations, and your work will be reduced many folds. You do not have to write a huge number of lines of commands, but you might activate the subroutine from time to time. We will have examples of that discussed in our discussion on programs. So, let us have a look at different options present inside a program. We might be having mirror imaging option. As the name implies, if you have a bilaterally symmetrical job, that means it is symmetrical on two sides of a central line. If you have a bilaterally symmetrical job, in that case you can call mirror image, program for one side only, and use a repeat loop to do the other side automatically after calling for mirror image. This sufficiently reduces the number of lines and possibilities of errors, etc. Linear interpolation is very simple, we have already discussed it. Circular interpolation, we have already discussed it. Tool length offset means that each and every tool which is used on the machine, they are not integral parts of the machine. So, that the machine has absolutely no idea what is the length of the tool protruding outside the spindle after mounting it, and what is the height of the job which is being done at present. The machine only understands, only knows about dimensions up to the spindle nose and the machine table. Beyond that, if something is loaded on the spindle or placed on the table, their dimensions, the machine is completely oblivious about those. So, we have to declare to the machine in some manner what is the length of the tool protruding from the spindle and what is the job height above the table surface. So, this way we also have tool diameter offset. That means, if the tool diameter is a certain value, we mention that to the machine, so that if milling operation is to be carried out, the machine can take a decision where to place the tool, so that the correct geometry is machined out. Subroutine call, as we discussed, when we are clustering a number of commands in a particular separate program, we can give a call to it maybe several times in a program in order to execute. Canned drilling cycles, we sometimes put a number of items in a can, number of say food items, sweetmeats you will be putting in a can, and that becomes a single unit. In the same manner, you can have all the operations required for drilling put in a single cluster, and you can refer to that particular cluster of operations just by a single G code. So, that your effort at writing lines of program commands, that is reduced. So, this way we can have canned drilling cycle, canned boring cycle, canned, so many cycles of operations are there. So, repeat loop is simply do loop as used in ordinary programs. Cutter diameter compensation we have just now discussed, we will have a quick look when we are actually doing the program. And cycle cancellation we have already discussed, G40, G49 and G80. Let us have a look at an actual program. What is this program about? You can see that there are 3 holes to be made, okay, three holes to be drilled at the circumference of a circle. That is good. Only holes? No. It might also, this program will also solve the problem of 3 weldments to be made, okay, or 3 solders to be made, or 3 what do you call it, enlargement of existing holes to be made as these 3 locations. Are the locations constant? No. If you use this program that we are going to discuss now, these values can be different. You can call a subroutine which is tailor made for handling this particular pattern of machining operations, machining or whatever manufacturing operations we are going to deal with. So, this is understood. 3 operations need to be done at 120 degree apart locations at a definite radius. That is all, nothing else. So, let us have a look. What have we a lot of material seems to have been written. Let us quickly go through it, what it means. Okay, in this example, there are 3 holes to be drilled at intervals of 120 degrees. The holes are centered around a point 20, 30 and at a radius of 32 millimeters. So, the radius is 32 millimeters, pitch circle radius is 32 millimeters, the diameter of the holes 5 millimeter holes, and the center of this pitch circle is 20, 30. So, it is not exactly at the origin, mind you, and the first hole is making an angle of 50 degrees with the positive direction of the x axis, and this can be done in conventional. Yes, we can do this in conventional drilling. How will you do that? Well, what we can do is we can use an indexing head, place it with axis upright, that means vertical on the machine table, and use a vertical drilling device to drill these holes, and the indexing head can rotate, so that sequentially the hole positions will be just under the tool and the drill will be drilling them. So, indexing head can be used, or you can even mark it out and then drill these holes, or you can use a rotary table, etc. That means either a skilled operator, or you can use physical devices. Rotating physical devices can be used, indexing head can be used, rotary table can be used, etc. So, physical rotation is being given. In order to give this physical rotation, the problem is we are having to buy some equipment. Indexing heads will be expensive and they will be prone to errors. So, in CNC machine, as the philosophy is to get rid of physical devices, to do away with skill of the operator, etc., we are rotating something else. We are rotating the coordinate system. Virtually the coordinate system rotates, and it takes care of the rotation which was required in the physical world in the conventional machines. So, we will simply rotate the coordinate system and repeat the drilling action. So, it will be drilled automatically at the 3 locations. Let us have a quick look how this is going to be done. This is the basic program. We start in the first line, okay, and in this program we are taking the help of E parameters, okay, and we are also taking the help of G codes, M codes and 3-letter codes. So, first of all, the first line reads that T 1.2, that means a tool is being mentioned, tool number 1 with offset written in the second line of the offset file. Now, that is a bit complex to understand. Let me express it once again. Tool number 1 is being asked, is being declared, and the offset, that means its length and diameter offsets, will be written in the second line of a file called the offset file. Okay. We will take it in more details, but at this moment we are declaring the tool number and we are declaring its offset. That means its length details and diameter details, and M06 asks the machine to load this tool onto the spindle, and it is declared that the spindle speed will be 400 RPM and the feed whenever required will be 50 millimeters per minute, and M03 starts this spindle. So, at the end of this command we will find that the tool has been changed and the tool is rotating, that the spindle is rotating with the tool at 400 RPM. So, after that we are defining some E parameters. What are E parameters? Just like we have variables in algebra, E parameters are simply variables which can be assigned some values. So, first of all, the center is at 20, 30 and we are assigning those x and y values respectively to two variables called E30 and E31. So, these are very strictly handled, so that E30 can only be assigned such dimensions referring to say the coordinate values. So, E30 is 20, E31 is 30. So, we have to designate these values in the initial program. So, in the main program we are first having designation of different E values. E32 is 32. What is that? The pitch circle radius. It is sometimes referred to as grid radius. So, E32 gets assigned this value, E33 gets assigned the starting angle, the angle which is made by the first whole meridional line with the starting with the positive x axis. Okay. And E34 is the pitch angle, that means the angle existing between two successive holes. After that, E1 reads the total number of operations to be executed, which is 3 in our case, and E36 is the small distance which will exist between the drill position and the plane of the workpiece top surface when the drill changes over from fast motion to feed motion. The drill when it is coming down to drill a hole, it moves fast, but changes over to slow motion, feed motion of 50 millimeters per minute only when it has come to a predetermined distance above the job surface, and this is being designated as 3 millimeters. So, the drill is being asked change over from rapid to feed motion at 3 millimeters above the job surface. After that, E37 gives the depth of machining. E37 is equal to -10. E2 defines the particular cycle that we are fixed cycle that we are going to carry out. This fixed cycle 81 pertains to drilling. After that, Cole's subroutine is depicted by CLS, a 3-letter code, and subroutine residing at line number 200 is being called, and therefore, we move on to the subroutine residing at line number 200, which starts with UOT. Use origin translation. So, with respect to the origin depicted as 0, which is the machine coordinate system origin, we are supposed to shift the origin to the point x E30, y E31. That means by 20 and 30 respectively, because E30 is equal to 20 and E31 is equal to 30. So, shift the origin with respect to the machine coordinate system, which is given a designation 0, to the point offset to this machine coordinate system by 20, 30. So, we basically have simply an origin translation. After that, repeat. RPT stands for repeat loop, do loop, even number of times. That means, if we have 3 operations, those many number of times this loop should repeat. After that, URT goes for a coordinate rotation. So, the coordinate is supposed to be a coordinate system, as we discussed, is going to be rotated about the z axis by the angle 50 degrees. E33 is 50. That is good. So, it is rotated by that angle. Therefore, the positive x axis is now passing through the positive x axis, first getting offset and then getting rotated. It is now passing through the first hole, and the first hole is residing at the point 50, 0 in this rotated and offset coordinate system. So, after that, in line number 203, we are having GE2, which means G81, which means can cycle start, R E36 and Z E37. So, it is a declaration to the machine that get ready for the moment I declare a coordinate value, coordinate position, carry out drilling with R means the changeover location from fast motion to slow motion R E36, that means at 3 millimeters above the job surface, and Z value E37 go to a depth of minus 10 millimeters below the job surface. I am always saying job surface because after you have declared tool length offset, the job surface becomes Z equal to 0. Next, we declare the coordinate location. Coordinate location is x equal to E32. What is E32? And rotated, therefore, the location of the first hole position is nothing but 32,0, and a hole is made at that point due to this particular line 204. After this, the angle is being updated as E33 is equal to E33 plus E34. So, whatever was the value of E33, we add E34 to it. So, 120 degrees is being added, and therefore, the angle depicted by E33 is now being changed to 50 plus 120. So, if it is 50 plus 120, therefore, G80 by the way G80 cancels the drilling cycle because we are not drilling after this, and we go for end of repeat, that means the do loop ends. So, this do loop is going to be repeated 3 times. So, again we start the do loop and it goes to URT E33. E33 has changed now, it is equal to 50 plus 120, and therefore, the coordinate system gets rotated so that the absolute angle of rotation is now 120 plus 50. So, the already rotated coordinate system undergoes a further rotation, so that the rotated angle is 120 plus 50 now. So, it is now at the second hole location, the positive x axis. Again the hole will be drilled at the on the x axis at 32,0, and the second hole will be drilled now. So, this way first hole, second hole, third hole gets drilled, and after that it comes out and comes to line number 208, which reads use absolute origin 0, which means that offset is now cancelled. The 2030 program shift coordinate origin shift is cancelled. The machine coordinate system is restored, and URT cancels the rotation. That means use rotation of 0 degree. So, now the rotated axis is now restored to its original position. It comes back to the program at G00 Z20 M05. G00 means fast, move up to the level 20 millimeters above the job, so that the drill comes out, I mean comes up to a safe position, and M05 is M05 is spindle off. Okay. So, at the end of this program, we will have 3 holes drilled at the locations required, carried out by the execution of a subroutine, made use of what you call it, the E parameters and some G codes. Thank you very much.